yesterday, we have written a nice little procedural macro that we can use to generate parse impulse for the CSS property values. And you can see an example of that right here. We have either a color value or a transparent or inherit keyword for a background color value. That's pretty simple and it works very fine, but I need to extend it a little. So what I want to do today is first I want to rewrite the macro so we don't work with these strings anymore, and instead I want to use the quote library, which allows us to, yes, they have an example right here, which allows us to use Rust code and get syntax highlighting, but under the hood it more or less does a similar thing. So I want to use that. And I don't expect that to take too long. I think we can do that pretty quickly. And after that, I want to be able to support more of the component value combinators, which is sort of a regex-like syntax used for CSS parsing. I want to support more of that inside of the macro, so we can parse more property values. For example, the CSS display property, which you can see right here. And as you can see, it is rather complex. It has many different options, but I will get to that in more detail once we finish using the quote library. Okay, so first thing we should do is actually import quote, I guess. That's quote version 1. We checked that yesterday, and we also need proc-macro 2, because I saw on the crate page, on the documentation page, that they use proc-macro 2, because the proc-macro 2 is basically just a re-exported version of the compiler internal proc-macro library, so that it can be used in crates outside of procedural macros and in unit tests, etc. And I believe that's also version 1. Okay. And then we can kind of rewrite this such that we don't use strings here anymore. Instead, we use the quote macro, and we basically write the same thing. Like this. Don't need the double brackets anymore. And then here I want to insert the value type dot type name. And no, that's the variant. I'm messing it up. This one should be the value type name, and this one should be the variant. So I guess I need to import. Well, the image is not loading. That's weird. So I guess I need to import the quote macro, probably. What are you complaining about? Cannot find macro quote here. So I need to use quote. And then what are you complaining about now? The quote value type 2 tokens is not satisfied. So I suppose I need the actual identifier probably. Value type dot variant type. Yeah, maybe let's scratch these structs maybe, because I'm not sure if we can use this the struct field access syntax within the quote macro. So let's maybe just change it to type name variant. And then we are inside the value type code. So I do want the value type name and the variant dot ident. Right, because I believe we do need the identifiers. And did I? No, I did explicitly state the vector type in here. That's not good. Don't need to do that. Okay, so now I want just the type name and just the variant. It still doesn't work. Expected empty type found token stream. I suppose I do need to delete the part down here. Yeah, and now it works. And now it's complaining because, of course, we're no longer using strings. We are using token streams. And I want to collect these into a vector, or do I want to join them immediately? Can I just concatenate them? And I suppose I should also import tokens. I guess I could import it as token stream 2. Use proc-macro 2 token stream as token stream 2. I guess that's reasonable. So I want to collect it as a token stream, and now I wonder whether it will just concatenate it all for me. I guess it's not complaining anymore. Then let's do the same thing for the keyword code. First of all, let's get rid of the keyword type. Don't need you anymore. You can go as well. And then in the future, I just want you to be the keyword and variant.items. Right? I think that's right. No, you shouldn't be a literal string. Or actually, you can be a literal string. That's fine. It's a keyword after all. It's a string literal. Makes sense. Okay, then now I want you to be the quote macro, and you don't need the string thing anymore, and don't need you anymore, and you can just be the keyword, and we want to map you to the variants. Of course, I need to add them in here as well. Keyword variant. Don't need these arguments anymore, and that should be it. Right, and we want to collect you into a token stream as well. But actually I need to add the comma now. And hopefully that just works as expected. If not, I'll be disappointed. Okay, can I just take a reference? Will that cause lifetime issues? Cannot move out of variant.ident, which is behind a shared reference. I do not want to do that. It's actually fine with a reference. Okay, cool. Very cool. Okay, so now I want to use the quote macro in here as well. Then let's go ahead and do that. Don't need you anymore, don't need you anymore. All of these can become single braces, curly braces. The nice thing is that now we actually get syntax highlighting, and it just becomes way easier to debug. Did I remove... I might have removed one brace too much. You should belong to this one up here. So why don't you do that? Because there's one still left in here. Okay. And then we can no longer get an invalid Rust code error because we're using the macro, which will always produce a valid impl. So let's, I guess we can just do this and then .call.into on it. And remove this down here. Will that just work? That would be very nice. We are not using the keyword match at all. That is not great. Let's include them in here. And let's add the value type code here. Value type code. Again, variable names are not that great right now, but I also don't really care. And we don't use the enum name anymore. That is also not correct. We want to use the enum name. Please give me the enum name. Enum name. Okay. And that seems like it could work, but we're getting an error. Expected pattern found comma. All right, because I have still have the extra comma in here after the keyword match, because all of them now have their own commas. No method name type name found for enum constructor. I don't want to call a type name function. That seems like I forgot to escape something. Yeah, I did. Just variant. Yep. And that should work, maybe. I believe in the dream. Not seeing any errors. Does it still pass fine? It takes a while to compile, but it looks like parsing is still as usual. Okay, great. So I think this is a no-brainer, really. It's very obvious to me, or rather I think it's very obvious that this is a good change and that we should keep it that way. Yeah, Rust format still wants to complain a little. I wonder if I should change anything else. I think the panics are all fine. Yeah, I think those are fine. So let's commit this. Git add web CSS property derive, and I want to add everything, I believe. Yep. And then also add cargo.log, but I still have some other changes. Yep. Yep. Okay. Good. Then let's commit that. Git commit CSS property derive. Use quote instead of strings. Problem is that the crate name is so long that there's not that much space left for the actual commit message. This allows us to get stuff like syntax highlighting and auto completion in the editor. It's a much nicer editing experience. Because the code as we had it previously was kind of a mess, to be honest. It was not really pleasant to write or read. Very cool. By the way, regarding my use of dependencies, I generally try to use as little dependencies as possible within the browser, at least at runtime. But for procedural macros, Rust proc-macros, basically you have to use these 3 crates that I've imported here if you want to write any kind of serious proc-macro. It just doesn't work without them. And I don't really count them as dependencies, because the way Rust dependencies work is that the Rust Foundation will kind of push responsibility for certain features onto the community to develop these kind of crates, as they've kind of done with, of course, these 3, but also async runtimes are a good example of that. And then once these crates in the community are performing well and they're kind of a clear winner has emerged, then they'll try to integrate them back into the standard library. So I am fine with these 3 dependencies. And of course, they are also just used at compile time, which I believe is fair. I mean, you can certainly try writing a macro, proc-macro without syn. Good luck. I should add space here. Do I not format cargo toml files? Let's add this as well. Commit, amend, no edit. Nice. Okay, on to the second task for today, which is supporting component value combinators, so we can parse the CSS display value. So as you can see, there's a clear list of combinators that we can use. And right now, the only one that we support is the bar operator. So in the code, that looks like this. We have either a color or a transparent keyword or an inherit keyword, but nothing else. And that is exactly what the bar operator does. Separates two or more alternatives, exactly one of them must occur. But I also want to support these three operators, and then brackets, the last one, we can just support that via types, that's not a problem. But I want to add support for these three. So first of all, we have just the space as a combinator, which means that the component is followed by another component and both of them must occur. And then there's the ampersand, which means that we have two or more components, all of them must occur, but the order is not relevant. And last but not least, the double bar means that there's two or more options and at least one of them must occur, but others can be left out and the order is not relevant. And the way I want to do this is by adding something like pub-enum display value. And for example, the display value can be a display outside or display inside, but the order does not matter. And you can also leave out either the display outside or the display inside. So what I want to do is add a variant that is a struct. I'm not quite sure what to call it right now. It doesn't matter for now. This is just a placeholder name. First is apparently a keyword. Okay, let's call it foo. Doesn't matter for now. Capitalized, of course. And then the struct will have two fields, namely outside, display outside, and inside, display inside. And those should both be optional because you can leave one of them out. Technically, this would allow for the both to be left out at the type level at least. Of course, the parser won't tolerate that, but the type itself would allow for that state, which is not really great. But I think that's something that we just have to live with for now. Because the only other option would be to create a sort of sub-enum, which creates all the possible combinations, and that's going to grow exponentially. So I think it's fine to just store these as options for now. And then I would annotate this struct field with something like, in this case, it's unordered. Right. And I guess while we're at it, we can also add a spec link. I try to add spec links everywhere where it's possible. Derive this stuff. And then I guess we can sketch out display outside and display inside as well. I think those are very simple. Display outside, right, this just for different blocks, for different keywords, I mean. Clone, copy, debug, partial equal. Wait a minute. Because I didn't type the enum before. Partial equal, and then of course CSS property. And then we want to create an enum of display outside. And display outside can be either a block, an inline, or a run-in. Okay. Block, inline, run-in. Okay. And then this is a keyword, which is block. And this one is a keyword that is inline. And this one is a keyword that is run-in. And it passes. That is very nice. I like this macro a lot. And I believe the display inside is just as simple. So we're gonna sketch that out too. Display inside, yeah, right. It just has a few more variants. Need to update this backlink as well. Okay, it can be either a flow root, a table, or one of the other ones. I don't really understand what Ruby elements are. I haven't seen them anywhere before on the web. They're probably one of these really exotic features that no one actually uses. But I guess at some point we'll have to implement them as well. We'll do it when we get there. Not Ruby. All of these need to become keywords. This is kind of cumbersome, but there's no way around it. I mean, writing an actual parser would be way, way, way more cumbersome. Keyword equal flow. Then we have a flow root with a dash in between. Flow root. Then we have a table. A flex. A grid and a Ruby element. Very nice. Okay, so that's those properties just for example. And then if the display value could, for example, have another field like bar, and it's just for demonstration purposes, let's add the same. But let's say that we care about the order, then we could add an annotation here, not ordered, right? And what was the last combinator that we need to support? We have this one, we have this one. So I guess for the last one we would have optional unordered. So I believe this one would actually be optional unordered and not just unordered. Okay, so we need to basically add 3 more keywords, and we need to add support for struct fields. Proc-macro derived panic. Yeah, I guess that's to be expected that our macro panics for now. Okay, then let's go into the code. And then down here, I guess we want to check if it's a struct variant. Check if it's a struct variant. Like foo bar bus. Okay, and how do we do that? One other thing that I'll at some point need to think about is that the outermost container, that one can of course also be a struct, right? Because right now we kind of assume that we have a list of variants that could occur, but it could also be the case that the outermost thing is just an optional unordered struct. But I think that is very rare because almost all properties support the inherit or initial keyword, and that makes them an enum. So it is definitely something that we can worry about later. Okay, then I guess let's go back to the syn documentation and find out how we can parse structs. Syn. I never know how to pronounce syn, by the way. Item enum. Attributes. Right, we are inside the variants, and now we want to find out if a variant is a struct. And I guess that's the case if the fields are named, right? Yeah, we have the fields named. Can we maybe I think we can clean this code up a little, because if it's a named field, then we have a struct variant. If it's an unnamed field, we have an enum variant, and if it's a unit type, then we have a keyword. But right now, this code allows us to specify a keyword for an enum variant, which is not really great. So let's maybe refactor this a little. Match variant fields. And if it's a syn fields named fields, then we just say to do, because we don't support struct field sets. If it's a unnamed field, then we basically want to paste the code that we have down there. Right. Yeah, we basically just want to use this code. And if it's a syn fields unit, then we can go and check if it's a keyword variant. Take this code and paste it up here. And then we also don't need this panic anymore, because we can panic in the individual branches if something goes wrong. I wonder if there's some nice way to prevent these very deep nesting levels with syn. I haven't found one yet. I guess that's just something that we'll have to live with for now. By the way, do you still panic if I comment out the new syntax, then it works fine. Okay, nice. So I didn't break anything with these changes. Okay, so if there's not a keyword attribute, then we probably also want to panic. Unit struct unit enum variants must have a keyword attribute. That's fair. And then if I test that out quickly, if I comment out the new syntax that breaks everything, and I also comment out this block, then this should panic because it does not have a keyword attribute. Nice. Is my Rust analyzer dying again? Yep, it is. Wait, is it? Something is panicking. Don't know what. Don't know if it's my code. That could actually be my code. Yeah, right. The panic message is CSS property variant must either have an associated parsable value or a keyword annotation, so that is just the proc-macro process that's dying. Okay. Then now we want to, if we have these named fields, then we want to find out whether there are any annotations on it. And we have three annotations that we support, namely, let's maybe make a comment for this. Find out if one of the three annotations exists on the field. We want to have either an ordered field, all fields required in exact order, or we want to have a unordered, which is all fields required, but order does not matter, I believe. Yeah, all of which must occur in any order. I can even link to the combinator. Very nice. No, that's the wrong one. And let's maybe put some quotes around that. That's just juxtaposition. This one doesn't have a link. Fair enough. This is just this backlink. I want the It's like the link to the combinator. All fields required, any order. And the last one is if it's unordered and optional. And how do I, what's a nice way? I don't really want to use optional unordered, because that's kind of two things. I could use two separate keywords maybe, like optional and I'm not sure about this. I guess optional could be fine. No, optional is not fine. I guess optional unordered is fine for now. I don't really like it. At least one field required. Any order. Okay, so we basically want to do the same thing that we have going on down here. Maybe we can simplify this a little. What does the syntax tree look like if there's... then it's not a name value. And instead it is a path. And this is a path. And I want to check if the path is or actually let path string equals this thing. And why is this even optional? Oh, right, because it can be, there can be multiple components to a path, and ident returns none if there's more than one component. How do I do this nicely? First thing that I want to find out is which one of the three variants it is, but then later I mean the code gen in general comes later, right? Let's struct types. Variable names in Syn always are confusing to me. And then a struct type is a... Let's create an enum for this. Enum struct field constraints, or maybe field constraints, and these can be ordered or unordered or optional unordered. And we want to derive the usual stuff for it, even though we probably don't really need it. Clone, copy, debug, partial equal. kind of the usual stuff that I derive for enums. Okay, and then I want to do let constraints equal match path string as deref, and then if you are sum ordered, then I want to return field constraints ordered. If you are sum unordered, then I want to return field constraints unordered, and if you are some optional unordered, then I want to return field constraints optional unordered. And otherwise I just want to continue. Just look at the next attribute, because this one is because this one is obviously not meant for us. We don't understand it, so ignore it. Okay. And then I want to probably get all the struct fields and their names into a vector so I can parse that one later. Right? How do I want to do this? I mean, what do I need to store? I need to store, let's just write it out. Struct types.push. And what do I want to push? I want to push the constraint that I just parsed, and then I want to also push a vector of the struct fields and their names. And specifically the struct field types and their names, right? Do I need the... yes, I do need that. Yes. Right. Something that I can do is actually add a impl for a parse imply for optional types. Let me quickly go ahead and do that. I'm going to go into the syntax, the parser, and then down here CSS parse. Everything that or an option that implies CSS parse should also be able to be parsed, because we just want to parse the optional type in that case. For option of t. Parse, and that is then a parser.parse optional value, and then I would just want to call tparse. Does that work? It does not, but where's the error? There it is. Expected result, right, because this can never fail, we also always want to return. Okay. I think we're going to need this later. Okay. So I want to collect all the struct fields and the types. Right. Collect all the field names and their types. Actually, can I maybe just store the named fields? What do the named fields look like in some named fields? Fields named was not fields unnamed. I want fields named. Yeah, so it's literally just pretty much a vector of fields. I can work with that. And the fields have ident, which is in our case is never none, and a type. Nice. And we can probably keep the type as is, I believe. Yeah, we can probably keep the type. So let's just store the fields named there. Don't need another reference in there. Cannot find value constraint because this constraints. So we don't need to collect this. And then down here, why is Rust Analyzer dead again? Still dying because of my macro changes. Wait, why are you unhappy about this? Oh, right, because for debugging reasons, it's also very painful to debug anything if the T doesn't imply debug. And debug, I think, is a reasonable constraint, so CSS parse requires debug. Okay, so now later in the code gen, I want to iterate over the code again, so let's add it down here. Let struct variance code equal, what did I call it? The variable names are just terrible. But I mean, they are also abstract, so I don't really know what else to call them. If you have any idea on what I should call them, then maybe let me know. I'm open for any suggestions at this point. Okay, so we have a constraint and a named fields. And we want to collect that into a token string 2. Okay, and basically we want to match on the constraints, of course. And if let's start with the simplest case, if it's ordered. And then if it's anything else, let's just panic for now. So if we have an ordered thing, then we want to parse each field as is, basically. So let's let parsed field equal how do I want to do this? This is really not easy. Oh, I guess I also need the variant name, right? Yes, I do, of course, need the variant name. Add variant.items. And then in here, I need to add this. Okay, so I Rust format, don't be annoying, please. This is going to get large. Trust me, I need the braces. Oh, Jesus Christ! I have format on save on. This is really annoying. Okay, let's just start writing code, and then maybe it will get it will at some point understand that it's not that simple. So now I want to iterate over the named fields, iter.map. Oh, I need to iterate over the, what attribute is it called? What's the attribute called? Named. Rust format is really annoying me right now. And if I iterate over that, I guess I get just the fields, probably. And I want to quote that into a let's do it like this. That bracket is too far outside. Let's get the field name. Field name equals field dot ident dot expect named fields always have a name. So it's fine to panic there because we know that we have named fields, so the name should never be none. And then we also have the field type is field.type. For whatever reason. I really don't like shortening your names like that. He's sad having the most terrible variable names ever. Okay, field name, field type dot parse with the parser, and I want to try and parse it, and then if parsing fails, we just abort. And then I can collect this into a token string true. Okay, will Rust format please stop removing my braces now? And no, it won't. Why? So annoying. Yeah, references are fine. And then sref, then we can unwrap on that. Okay, so that's all the struct field parsing, and then I guess I need to add a let's field parsing. Yeah, I guess if I do an assignment here, then it might be happy. Rust format might be happy with me. Yeah, there we go. Okay, and then I want to quote again, and I want to self and the field parsing code goes in here. And I think that's it. For the ordered code, at least. This is really getting quite complex now. Oh, right, of course it needs to be the variant. I was wondering why we didn't need the variant here, but of course this should be done like this, and then we can wrap that in a parse optional. But this code now tries to parse the things in any order. Now let's move on to the more complicated cases, like the unordered case. Okay, so now we need to how do we do this? So the cases can occur in any order, and I guess if one of them matches, then none of the other matches, right? So we can never have something like, for example, A or AA, because then if we pass the value AAAA, or rather we pass this, then it would be ambiguous. And I think CSS parsing is just never ambiguous. So we should we should maybe keep a list of values that we are still missing. Maybe this should actually be a parser function. No. I need to keep track of which options have already been parsed. And this also doesn't need to be super optimized, I believe. No, it kind of does need to. Okay, but we don't need to worry about performance too much for now. Okay, then let parsed fields equal none, and we want to. Yeah, this is fine for performance. It doesn't matter too much. And I want to let number of fields equal hashtag named fields dot named dot len. So that is the number of fields, and in the beginning we have no fields passed, so everything is just none. And this is a hashtag. Right, and this all needs to go to a quote macro. It's kind of confusing to see Rust code mixed in with the quote macro code. Kind of hard to distinguish it. Okay. So in the beginning we have no fields, and then for in 0 to number of fields, because we need to pass all the fields. And then we want to iterate over all the values in the passed fields. For value and parsed fields, iter.filter. And I want to iterate over it mutably, so I also need to declare this as mutable. And then I want to filter all of those out that are some, editor none. Field dot is none. I don't get the inlay hints, and I've come to rely on them quite a lot. So now we should try to parse that. If let some parsed value equal parser.parse optional value, and we want to try and parse the type of the field at the given index. Is that right? Oh, yeah. So I need to also do that compile time. Parse fields. Let parse fields, and this should just try and parse code to try and parse each field of the struct once, reporting early if parsing here succeeds. Right, and then if it succeeds, if parsing succeeds, the value is written into the parsed fields array. Right. And oh wait, I think I'm overcomplicating this. Yeah, I don't need to store this as a separate thing. I'm really confusing myself right now, sorry. I think my commentary is also getting kind of incoherent. Wait, I do need to unroll the for loop. Because right now I don't know which type I need to parse. Wait, am I just... No, I can't even use the array thing like that, right? Because of course I'm storing different values in there. So I just need to use... Okay, I need to unroll everything. Yeah. So let's write something like field initialization. Initially, every field is none, aka has not yet been parsed. Field initialization equals and then I want to iterate over our name fields. Name fields, iter. And I want to enumerate it for convenience. And then I want to map this index field pair. And what do I want to map it to? String 2. I want to map it to field underscore index, and this should of course be inside a quote macro. Field underscore index equals none. So I guess I don't even need the field information in here. Zero named fields dot named dot then I don't need to enumerate this. Then this can also become the number of fields. Consider adding white space here. Now I want to create why is this not valid? Because I don't have an index. I want to create a new variable name, unknown literal prefix. I want to create something like field 1. Is that? Oh, I'm just an idiot. I am an idiot. I'm a complete buffoon. No, it still doesn't work. Maybe without the underscore. Maybe it's a... I'm not sure this does what I want. sure I'm not the first person with that issue. Rust quote, create new identifier. How can I create hygienic identifiers? Okay, so I guess I can create my new identifier. Okay, is it stable by now? It is not stable. But I'm not scared of nightly compilers. I mean, the whole browser builds on nightly anyway, so I guess I can use the new syntax. Syn ident new, and I have a format. Index, and then the ident is syn span. Is it no, it's not in syn. It's a proc-macro 2 span. Does it not have how can I create an identifier? No, proc-macro 2 does have a span struct. Rust analyzer is just drunk. Why do you not like my code? Of course I need parentheses around this part. Takes 2 arguments, but 1 argument was supplied. Am I not closing my parentheses? I'm closing too many of them. That's the problem. No function named dev site, right? Because I do need to enable a feature. Let's look at the documentation. Proc-macro 2. Unstable features. Oh god, this already sounds like a pain. Okay, let's just use the call site instead of the definition site. I don't really care where the identifier ends up. I really don't care. Do I not need to call iter on a range? Apparently I don't. Very nice. And then I need to borrow here. And now this can just become a field ident. And I suppose I should also collect these in a separate vector. idents map the index, and want to map the index to this thing. Collect, and I want to collect it into a vec of some idents. Need to remove the semicolon. And that works now, and now I don't want to iterate over the index anymore. I want to iterate over the field idents. And this should be an ident, and this is an ident. Nice. Okay. Then for each iteration, wait, why is everything red? Is it because of you? It is. Okay. So now I want to try and parse each field, so that I need to iterate over the field idents again. Do I need to iterate over the field idents? Yes, and I want to zip the named fields.named. Right. And then, nope. And then I want to map these, and I have a field ident named field, and I want to map them and collect the result into a token stream too. Okay, and then the next step is just proc-macro here again, and don't like spaces after that. And if we have some parsed value is parse or the parse optional value. By the way, I'm sorry for my lack of high quality commentary right now, but this is kind of really complicated to think about. So I'm kind of distracted. I'm sorry for that. So if we have a passed value, then first of all, after that we want to break out of the outer for loop. No, we want to continue this for loop here. And before that, we want to write to the field ident. And the field ident should then be some the field ident should be some of the parsed value that we just parsed. And now what exactly do we need to parse? We need to parse the named, not named filed, named field. We want to parse the named field. I need a type first. That field type named field.type. Want to take a reference, of course, because we can't move out of that. Or right, I can't move out of that either, so we don't need to take the reference down here. We do? We do. Never mind. Apparently we do. Okay. And now I want to call field type parse. Awesome. Okay, so at this point, and then right, if we haven't continued down here, then we want to return error, parse error. And let's also add a comment. If we did not continue yet, none of the fields parsed successfully, which is an error. passed successfully, which is an error. So at this point down here, everything should be sum because everything has been parsed. Wait, this isn't right. I need to first check if the value even is none. Field ident is none. And if it is not none, then we shouldn't try and parse it again. Okay, this is all building on the assumption that that fields can never be prefixes of each other. So at any given point in time, at any point in this for loop, only one of all the fields will successfully pass and all the others should fail. Okay, and now we can basically just return, okay. No, we want to return the self variant. And there we need another substep, field readout. For lack of a better name, again, it's not great naming, but I think this one is actually one of the better names. Okay, let field read out equal. I want to iterate over the field idents again. And I basically want to do the same thing as up here. And I want to map this once again with the field ident named field. And then I want to collect the result to a token stream too. Okay, and what we want to map it to is first of all I need the I need the field name, named field dot I don't want to have field name and field ident in the same thing, but again I can clean up the variable names later. Field name equal named field ident unwrap. And I'm missing a pipe here, and this needs to be as ref, of course. Okay, and then we have the field name colon hashtag field ident dot unwrap. Okay. I think that's pretty good. Wait, why are we not using the struct variance code? Oh, right, that's okay for now. It's okay to not use this for now. And then the next one is the fields unordered. The optional unordered, and then there's no more to do because there's only those three options. And I basically want to do the same thing, but I don't want to panic. I don't want to return an error down here if nothing passes. In that case, I just want to break out of the loop and assign the fields. So it's very similar. And what can I reuse? I can't reuse the field readout, but I can reuse the parse fields and this stuff. Is it worth it? To separate those out? guess I don't really even need to... maybe I can do it like this. I can handle them both in the same case. Because they are the same up to here. And then even down here they're not that different. If constraints optional unordered. If it's optional, then we do this, else. So this is our old case, and in the new case we simply don't want to unwrap here. Does it not imply... Okay. Or rather I should add the... I don't want a reference in here, I want the entire thing. Huh? Why doesn't this work? That's weird. I thought it would work. I mean, I guess I can also borrow down here. It's not the end of the world, it's just kind of ugly. Okay. So if it is optional, then we do not want to unwrap. And then let's also introduce a handle nothing parsed case equals if constraint is field constraints optional unordered. If our fields are optional, then we are simply done parsing. So we want to break. Else, if our fields are not optional, then this is an error and we need to error out. Wow, this is really meta code, meta programming at its best. Handle nothing fast case, and then this needs to be, oh wait, oh, this needs to be up here. Wow, this code is quite something. Okay, and 1 second, let me quickly pause the recording, sorry. Okay, I'm back, sorry for the delay. We're just going to continue where we left off. So now I need to actually use the generated code for each of the different variants. So I guess I want to call this inside a parse optional value. So I guess these should all return okay as a variant, so we can properly handle the errors. This is okay too. And then now the struct variance code is now a piece of code that can try and parse the struct, the given struct, yeah, and or rather it's a collection. Oh no, this isn't quite right. I need to add another layer of abstraction here. Let parse struct, and then this should have a semicolon at the end. Why do you not parse? And then I want to basically call parser.parse optional value with the parse struct. Parse struct. And I need to think about this a little. Why does this not work? Let expressions are not supported here. I'm not trying to use a let expression. I think I messed up the brackets, the curly braces at some point. That's the first block. This is the second block. Alright, so I should put my stuff in there. Wait, why are these parentheses? These should be parentheses. And then I can move this down and hopefully, no, it won't format just yet. Why not? Do I need to add this? So this is the sort of the underlying let expression. And now we don't get any errors, but it also doesn't parse. Or at least Rust format doesn't do anything. Why? Let's just indent it my own. So this gives us the parse struct. I'm pretty sure that, I mean, Rust format does something, just not something very useful. I was hoping it could maybe prettify this a little, but this is going to do it for now. Okay, so I want to pass the optional value, and then if that returns some passed value, then I want to return self. Do we have the variant in here? Check variant with the. Oh no, actually I want to just return the passed value. And I want to make it okay, so we can use it outside another parsing function. And then I believe Rust format is really not doing its thing right now. But let's just include this. Suppose we can do it down here. Or is Rust Analyzer just dead again? Can I restart it? One thing at a time. Let's first uncomment this. This panics. Why does it panic? Because I did not declare these helper attributes. That makes sense. That's fair enough, actually. So we need ordered, unordered, and optional unordered. And it still panics. Not yet implemented. Where is there a to-do? Struct types to push. I think I just want to break. Do not? I mean, I'm kind of done here. Yeah, if we have named fields, then we iterate over all the attributes. Yeah, that's it. Don't need to panic there. And then cannot find value parse struct in this scope. Where is there a parse struct? Equals match constraint. And we're not using that. Because this should be a hashtag and not two curly braces. And it still doesn't compile. Wait, why? What? Why is this invalid? Comparison operators cannot be chained. Are we messing up some kind of parsing stuff? Because I believe this should be perfectly valid Rust code. No? Am I stupid? Maybe we should fix that first, I guess. Statement found outside of block. That is because we do not surround this by braces, which we should do. And proc-macro derived produced unparsable tokens. How did that happen? That shouldn't be possible. We are always properly quoting. Where is that panic occurring? Here. Okay. So maybe it is related to this. Wait, am I just messing up this syntax? Rust enum struct field. I mean, I rarely use struct fields because I usually just put a struct into an enum. But then again, I don't think I would mess up the syntax for that. Oh, come on, give me the enum that I want. Enumerations. Yeah, that's exactly how you do it. But now I'm confused. I'm not trying to display a const argument. I don't really understand, because whatever we add down here, that shouldn't really affect the stuff that is produced by the CSS parser macro should not affect the actual struct. Let's just undo that. That's kind of annoying. Do I get more information if I do cargo run? This shouldn't cause a bug. So maybe this is a compiler bug, because this is very clearly valid Rust code. Very, very clearly. And it should be accepted as such. But it did not panic before, so let's try and figure out at what point stuff goes wrong. So if I comment this out, then it's fine. But if I don't comment it out, then everything breaks. Oh, that might be because because of the call side. So the diagnostics are just not correct. We're just getting bad diagnostics from this. Because something in here is not correct. Cargo expound. Maybe, I believe. Okay, test. Okay, let's maybe make it test, just so we get syntax highlighting. Okay, and now I want to look for parsed fields, for example. Should be some, no, let's look for parsed keyword. Yeah. So that's the color value. That is the background color value. That's the display value. That's the one we're interested in. So we have two fields. Field 0, none. Field 1, none, right? Parsed fields is... Wait, why do we have... Isn't that redundant? We're never using parsed fields. So I can remove that. Wait, where do I even define that? Where's this line coming from? There it is. So we don't need U anymore, but this also shouldn't have caused any issues. Yeah, it's just a redundant line. And then apart from that, we iterate over this 2 times and say if the first field is none, then try and parse something empty. Well, that's not correct. Why do we try and parse nothing? We want the field type. Is it possible that the field type is just not existent? Let's just panic on the field type. I'm sure they implement debug at least. Yeah, there we go. So let's cargo expands. Cannot be formatted with question mark because it does not. I mean, either way, no, either way, this can't be right because do we need to add a space here? Let's see. No, this just does not work for some reason. Why? Oh, something else I just remembered is, can I just add a fix me for that? If we are optional unordered, verify that at least one value has been parsed. That is something that we should do, or rather that we need to do. Okay. Is this even like the code that I'm looking at? It's not. Except, does quote remove the... Wait, this is... These ones are also wrong. Why is it bar? Oh, because I added the foo bar stuff. Right. Does it still panic if I only have bar? Yeah, it still panics. Okay, then let's maybe use that as a reduced test case. I am so confused. Does it not resolve these attributes? Let's display outside. I just want this display value. Yeah, right. Okay, that's the keyword parser. And I guess the compiler can optimize this part out. I don't care about that for now. And then yeah, this seems broken. This is definitely not right. Wait, why are we even constructing bar anymore? Oh, right, because we have this, right? But why does it fill in these types? I am confused. Does it work if I just do what it says and add these ones here? Rust format immediately removes them. Okay, but I shouldn't even need to remove them. Okay, first of all, why can this not fail? Why can this not fail? So apparently we can't really deal with these types very well. What is a syn type? It's one of those. But what I really want... No, a type should be fine. 2 tokens. So I can convert this to tokens. So what happens if I just for testing, I mean the field type is obviously wrong, right? So what happens if I just panic and give myself the field type? Field type dot to token stream. Rust analyzer is also dead again. What? But it literally is. Oh, feature printing. I think there's a debug feature in Sin, right? And then I can just debug the type immediately. It's called extra traits. When does this thing imply debug? Extra traits, okay. So let's just for testing, we can take this out later, add the extra traits feature. And then we don't have to use to token stream and can simply panic on the thing itself. And hopefully that should give us some more information. Nope. We do not panic at all. Why do we not panic? Do we not hit this code path? It is inside unordered or optional. Oh, right, because right now we are in the ordered section. In the ordered section, and then let's add this here. Please panic now. So we get this path. Generic argument type. So that seems fine. Why does it not work? I mean, I've done something similar previously, have I not? For the value type code. Here, it's type name parse. Oh, but then type name was just an identifier in that case. So maybe I can't. I want to see what this looks like as a token stream. So let's add the printing feature and then panic on the to token stream. Then we want to use quote to tokens. Okay, we have a token stream. Okay, so first we have an identifier option. Great. Then we have this symbol, then we have identifier display outside, and we have a closing symbol. Is that not what we want? I'm trying to figure out what I'm doing wrong. So this can be any one of these. What's a type group? I don't know. Panic. For whatever reason, we can't use the type just as sort of a literal thing. For whatever reason, that does not work. Although I think it should. Oh, maybe because do I need to do something like field type as CSS parse? Maybe this. I'm not seeing any errors anymore. That can be good or that can be bad. Okay, let's go back a little and try to run it. It does compile, and let's see if let's remove this for a bit. I mean, at least it compiles now. Okay, so let me quickly explain what I believe the error was. I think that I am in my code, field type is only ever an enum or a struct. It's never a type like, for example, a slice of U8s. But I think if it was a slice of U8s, then you couldn't use this parse syntax because that's not legal Rust syntax. So I assumed that it would. So in this case, quote just recognizes, hey, this is not how you can use a type. So first I need to cast it to CSS parse to use the trait object, or rather use its trait functions, and then I can call parse on it. And hopefully that was the only error, and now it works fine. Let me see. Okay, so now it expects. Wait, if it's ordered, then it should never. If it's ordered, then it shouldn't be optional. If it's ordered, then it should just work like this. Okay, then let's try to... Wait, ordered means that they need to occur in that exact order. Yeah, right. So it needs to be a display outside and display inside. So let's try and parse block flow. Display block flow. And I just recognized that that can't work because we need to skip white space in between. Yep, white space is definitely going to be an issue. Let's skip white space in between the struct fields. A CSS parse. Oh no, the individual parsers, they should take care of white space for us. So each call to parse here should take care of any trailing white space. Let's see if that's actually the case. Inside the keyword match, parse optional value. Yeah, I do not currently skip white space. Skip white space. Parsed keyword. And then we can just return an error here. Yeah. And then we can return OK of parsed keyword. And then I need the functions up here to no longer return an OK type. It does still compile, okay. Unreachable statement. What's an unreachable statement? Let's look at cargo expand again. Cargo expand into test.s. And let's look at display outside. So some value in here is apparently unused. What value is unused? Oh, it's unreachable. Unreachable statement, not unused. What is unreachable? I mean, I only changed this part here, right? What part of this is unused? Guess I can also simplify this part a little. Okay, let's actually keep it this part as is. Okay, but why does this cause an error? If I comment you out, then nothing is unused. Unreachable. Sorry, I keep forgetting about that. This is unreachable. No, it's not. Okay. Why is something in here unreachable? It's in display outside, right? No, it's not in display outside. It's in, I'm just stupid, it's in display value. And I mean, of course I can't find the unreachable part if it's inside another thing. Okay. Oh, okay. Now that generates a warning because whatever happens will return. So that is quite an easy fix. I just need to check in. And basically, we don't even want to generate this code here. Or actually, I could. I think there's an auto-generated annotation. That not. There's not. There's a compiler annotation that basically tells the compiler that it's auto-generated. Where did I put it? There might be one in DOM derive, so let's quickly look if I can find it in there. Automatically derived. Yeah, there it is. I basically want to use that, and that tells the compiler to more or less shut up and let me do my thing. And the compiler promptly ignores it. Well, that's not very nice. Automatically derived. I think that should cause it to... maybe not. Okay, let's simplify this. Okay, then let's pass keywords equals, and then actually automatically derived should cause it to be quiet about those things. What does automatically derived mean? Should not be reported as unused. Okay, I think there was an attribute that told it to not worry about unreachable code. Okay, automatically derived. No standard, no core linkage. Okay, I mean I can't find it right now apparently. Okay, then let's just figure out how we can not generate this code if it's not necessary. Okay, first of all, when is it not necessary? We don't need to generate any keyword code if the keywords is empty. If keywords.is empty, then this should be token string2 new, and otherwise we want it to be this entire block. And then now we want this to be parse keywords. Then we need a semicolon here. Rust format doesn't really play well with quote, unfortunately. But I can deal with that. Okay, and we don't get a warning anymore. Very nice. And then maybe let's also make the naming scheme in here coherent. Parse unit values maybe. And this could be parse struct variance. Yeah, this could be parse unit variance. Parse struct variance and parse unit variance. At least we're getting some kind of consistency in the code base now with naming schemes. Okay. So you should compile now. Let's see if you run fine. Unknown CSS property name display. All right, I haven't added it to the properties yet. So there's a display property, and this has a display value. And I need a spec link for that. Right, and then if we have a display, then I want to call self display. I want to construct a display with display value parse. Oh, right, with the parser. Then if it fails, we want to abort. Okay. Does that work now? Oh, that works fine. That is so cool. You can see what I mean right here. We have a properties array, and that properties array contains a display property, which has the property outside block and inside flow. And if I were to switch those, so if I were to say flow block, then that should not work anymore, because these are ordered properties, so they need to be in an exact order. Yeah, very nice. So now we get an empty array because there's no valid rule. Each rule, or rather the one rule that we have, contains an error. It can't be passed. That is very, very cool. Okay. Then I believe we need to apply the same fix that we had previously with, where's the fix? 1 second. Here, this one. We need to do the same trick for the unordered and optional unordered fields as well. So wherever we use the field type, luckily we don't use it that much, we need to replace it with field type as CSS parse. And this is very unhygienic because CSS parse could be overwritten by some other namespace, but we're not going to care about that for now. I don't want to worry about that. Okay, let's close some of this that we don't need. Let's go into properties and then enable this one, the optional unordered. So each field in here is optional, and we do panic. Expected the option of outside, and we found an option of outside. That sounds like we just wrap in some ones too much. So let's do another cargo response test.s and display value. Okay, that's clone, that's debug, and this is the CSS parse. Okay. Okay, so actually let's comment out the bar part. Oh no, it doesn't even matter, because the bar part should be further down if I'm not wrong. Yeah, this is the bar part, and this is the actually complicated foo part. Okay. So we have weird one, and field 0 is then an option. And why does this panic? Let's maybe add compiler annotations for the types, just so we can be certain that they are what we expect them to be. Actually, no, never mind. That's not trivial to do. Let's not do that. I was trying to add a type annotation here, so that way we can be sure that what this option contains. But let's not do that for now. Oh, right. We do not want to there's no point in parsing this optional value because we're trying to parse an optional value of an option. And that doesn't make sense. Instead, what we should do is what we should do instead. What should we do instead? That's not so trivial. I guess we just want to parse this. Just call this the parser. And then if this errors out, then we of course also want to error out. And if it is right. I mean, this can't error out because it's an option, but just add it there anyway. The compiler is going to optimize that out. Now we are up here. And let's just open another window, try to execute it. And it looks like we do compile now. And we get outside block, inside some flow. Okay, so if we look at this again, what we see now is that, first of all, this is now not determinate, so because bar is lower down, foo gets passed first, but otherwise bar would get passed first. But now we have these two values that are optional and unordered. And we get some block, some flow. That is correct. But if I were to, for example, remove the flow, then we should see some block and none. Some block and none, that is correct. And if I were to say flow block, then we should see the one up here again. So some block, some flow. Oh, that is beautiful. That is amazing. That is wonderful. Okay, then let's also check that something has parsed. So let's go in here. And if constraint is optional unordered, I'm trying to differentiate this from the handle nothing parsed case. Let's handle every field none equals if we're optional and unordered. Okay. No, let's call this verify parsed value. So if the if we are an optional type, then we want to verify that all the fields are non-zero. So how do we do that? And of course, otherwise we just want to not verify anything. So return an empty token stream 2. And then we want to call this down here. Okay, and the semicolon here. And now we want to check if this is none, and that is none, and that is none, and that is none. How can I do this nicely? And there must be an iterator join thing, kind of thing. First is the iterator. Okay, and I want to sort of flatten? No, not flatten. Intersperse. No, I don't want intersperse. I think fold might be correct. Fold takes 2 arguments, an initial value and a closure with 2 arguments, an accumulator and an element. There's a broken way to do this and there's a right way to do this, and I'm going to choose the broken way to do this. Because what I want to do is basically check, hey, if, one second, if field 0.is none and field 1.is none and so on, and then I want to panic. But there's no easy way to put an ampersand between all of these individual conditionals, but not before or after it. But what I can do is just put a true before it and then put a double ampersand in before every field. And that's kind of stupid, but it also kind of works. And so I'm fine with it. And ident.is none. And then I just need to an initial value. Oh, right, there's an accumulate method, no? I think something like... what if I want to fold, but I want to start with the initial first item? Ah, reduce. Reduce. Okay, so I don't need to do my ugly hack. I can just call ident is none and then say, hey, please reduce into I need to provide it with a get accumulator e, the accumulator and the element, and then I want to say quote. I want to add the accumulator and the e and hashtag e. And then I don't need to collect this anymore, I believe. I can just do unwrap, or does it imply default? Token stream new. Consider returning the local binding field initialization. What? Expected nothing, found a token stream. Oh, let all fields are none. And then I can do quote if hashtag all fields are none, then I want to panic. No, I want to return an error, a parse error. And then there should be a semicolon, not a colon. And this compiles. Okay, let's just check that I didn't break anything. I did not. And then let's see what happens if I don't give it any values. and it doesn't work anymore. Beautiful. Very nice. Okay, so that concludes the checks for optional unordered. Let's look at just unordered. I don't suppose there will be any bugs in there, but let's just find out. Unordered, and we panic. Why do we panic? Cargo expand into test.rs. I want to check for the display value, right? Okay, and why does this cause issues? Expected display inside found option. Display outside found option. This expression has type display outside. Oh, here. Of course. Okay, I see two ways to fix this. One of them is good, one of them is not good. How hard is it to get the first generic argument from a type? Or rather, if we have a type, named fields. Okay, if we have a type, how hard is it to get the first generic argument of that type? I guess type path is what I usually consider. Segments, no. I mean the generic. Do the generics not belong in there? Okay, let's just go with the ugly solution for now. It's not that great, but it works. That's good enough for now. Basically, we can't do this. Wait, why is there a foo argument here? A foo comment. Basically, if we are optional unordered, then we can do this. Otherwise, should have copied that whole line, my bad. Then we can do this. Otherwise, we have to actually pass an optional value there. And this is not really pretty because the code up here shouldn't be the way it is. Let's just keep it that way. Pass optional value. Where's the optional value? There it is. And we want to pass that type. And if that is valid, then we do that. Okay, that should be fine now. And it does indeed parse fine. Let's see what happens if I switch up the order. Block flow. And that also works fine. Very nice. Do I want to commit it the way it is right now? And this is kind of spaghetti code. But then again, it's not like, I mean, we're auto-generating a lot of rather complex code. So I'm not sure if there's even a simpler way to do this. I kind of doubt it. Maybe put everything together. Maybe we can add some explanatory comments. These are the switch arms in a match block. Match is the word that we use in Rust. Match arms in a match block that map from a keyword str to the corresponding value type. For example, let's just add something like this, and then foo is maps to self colon foo, and I just noticed that I added this comment on the wrong part of the code, because this one is actually fairly obvious, and this should be up there on the match arms, keyword match, I believe it's called, yeah, up here. Okay, this one is also quite simple. For each unit struct variant, for example, foo contained type, for each of those types, we try and parse the contained type, and if it succeeds, return that variant with the parsed value. Okay, I mean, there's a lot more that could be done in here. I'm not super happy with the code, especially with this part. Wait. Am I just shooting myself in the foot here? I think I am. No, wait. If we are optional unordered, then we don't unwrap down here, because it's fine for our values to not. Okay, okay. Sorry, I keep confusing myself about this. It's fine to not unwrap here because our values might not exist, because of course they're optional. And then it's actually kind of fine to do it like this up here as well. Yeah, I guess this isn't too bad. I'm gonna run it one more time just to be sure. Okay, nice. Then let's make a commit out of this. I won't commit the changes inside properties for now. Wait, what did I change about the parser? Oh, I do have to add this. But I'm not gonna commit the changes inside properties because there's a bunch of debug code in here, and I can add the display value later off camera maybe. Yeah, don't need to do it right now. Okay, let's make a commit out of this. I want to commit CSS property derive. What else did I change? I want to remove the test file that I made. I want to also commit the changes to the parser. CSS parser.rs. Why? Syntax. I forgot the syntax folder. And apart from that, I think that's pretty much it. The rest is either debug files that I want to keep around or just changes for testing. Cool. Then let's commit this. CSS derive. Let's call it CSS derive for just shorthand stuff. Parse more complex combinator values. Not great message, but either way. For examples of this, refer to the implemented CSS properties to be done in a later commit. Let's also add a link to the spec component value combinators. This allows us to express the CSS component value combinators as Rust types with annotations. Wait, I want the link to the component value combinators. That's the spec link. I want this link. Okay, let's add this. Very cool. Cool. That was some of the heaviest meta-programming code that I've written in quite a while. I mean, how long is this now? 300 lines of generating Rust code. It's quite painful, but I think the result is okay. Wait. If we are, there's a fix me here. If we are optional unordered, verify that at least one value has been parsed. But I just did this. This is literally what the code below, right below the fix me does. So let's git add CSS property derive and amend that. Okay, very cool. Then I think that's going to do it for today. If you stuck around until the end, then I thank you for watching, and I hope you learned something new today. See you all in a later video, and bye.